All right, calculus teachers. So next year when you get ready to teach integration and you'd like the students to understand and work with Riemann sums, here are a couple of the Riemann sum variations in Geogebra Classic. So click on the Geogebra Classic link. And I'll close these windows out here. I don't know why they always open for me. Kind of recenter my axes a bit. And let's type in a function. I'll go f of x equals the cosine of x times the sine of 2x. And I'll go plus 3 to get that above the x-axis. And then I would like to place a point on the x-axis to the left and on the x-axis over here to the right. And you'll notice it tells me point on x-axis, point on x-axis. And since we're dealing with Riemann sums, or their variations of, I want to create a slider that will give me the number of subdivisions in my sum. So n is going to be a slider with a minimum value of 1 and a maximum value of 30, and I want my step size to be 1. And so the first Riemann sum is, I'll call an upper sum. And that takes the function, and it's going to go from the x-coordinate of A to the x-coordinate of B, and there are going to be n subdivisions. And an upper sum, the height of each rectangle on the interval is determined by the greatest function value, or the upper function value, on that interval. Compare this to a lower sum. The lower sum takes function f, and it's going to go from the x-coordinate of point A to the x-coordinate of point B, and there'll be n subdivisions. In this case, the height of each rectangle is determined by the least function value on that interval. But this is a nice way to see that as the number of rectangles increase, the integral value is probably sandwiched in between these two things. We can compare that right now. If I go integral of f from x of A to the x-coordinate of B, we can see that the integral is actually between the values for the lower sum and the upper sum. Another Riemann sum is the trapezoidal sum. And it takes function f, and it will go from the x-coordinate of A to the x-coordinate of B. Let's try that again. And there'll be n trapezoids. And in this case, you can see your trapezoids. Now, they've not moved points A or B yet, but point A and B, they are dynamic. And if B happens to be to the left of point A, that area is computed to be negative. So it is assigned area. And the last Riemann sum variation is called a rectangle sum. And it takes the function f, will go from the x-coordinate of A to the x-coordinate of B. There will be n rectangles, and this has one more parameter that is between 0 and 1, and that tells us where the rectangle is kind of located on the interval. I'm going to choose 0.5. So the midpoint of the interval determines the height of the rectangle. If I went 0, the left end of the interval would determine the height of the rectangle. And if I went 1, the right side of the interval would determine the height of that rectangle. And I could also go in between, so I could go 0.75 if I wanted to. I'll keep that at 0.5. And again, these numbers are the actual values of the areas, so as the number of rectangles or the number of subdivisions increases, You can compare that to the actual value of the integral. And if you look at these two things, you can see that they're all pretty close.